we're working on our Unit 5 review, which is all about graphing quadratic functions. Let's jump into the first problem. It says graph the function and find the requested information. If you look further down here, you can see all the things that I'm looking for: axis of symmetry, vertex, y-intercept, x-intercepts, and then we'll use all this to solve the equation. So let's go ahead and start plotting. So first I'll find the axis of symmetry, which is going to be the first part of finding the vertex. Okay, it's x equals whatever that h value is. And we can use that same h value for the vertex as well. So I'll just say vertex is at h comma k. Okay, so we'll just start with that. So let's go ahead and calculate h. H is going to be negative b over 2a. And so this might be a good time to actually identify what a, b, and c are. In this case, a is 1, b is negative 6, and c is 2. So h is going to be the opposite of b, so that'd be positive 6 over 2 times a, so that'd be 2 times 1, which is 2. So 6 divided by 2 is 3. So we know that our axis of symmetry is at x equals 3, but let's go ahead and find the vertex anyway, and we'll just knock out both of those at the same time. The k is going to be calculated by going back and plugging in this number that we got for h back into this equation. Okay. So we'll get 3 squared minus 6 times 3 plus 2. So we have 9 plus 2 is 11 minus 18, negative 7, I think. Let me double check that in the calculator. Yeah, negative 7. Okay. All right, so now we've got all this information. We've got our h, we've got our k. I'm just going to draw a line here because the next step is we're going to do something a little different here. Okay, so our axis of symmetry would be at x equals, let's see, what was it again? 3. My vertex is at 3, comma, negative 7. Let's go ahead and plot that. Vertex is at 3, negative 7. So let's see, 3, negative 7 can be right here. So the vertex is that point right there. The axis of symmetry, you don't really need to draw it on here, but it's just basically this, this vertical line that's going to go through the vertex. Okay, it's not really part of the graph, but it can help you to increase the accuracy of your graph. All right, the y-intercept, that's typically the easiest thing to find. I'll make a note here just so we can have it all laid out. The y-intercept is going to be at 0, comma, and then whatever the c value is. Okay, so in this case, the c value is 2, so I know my y-intercept is going to be at 0, comma 2. And let's just go ahead and plot that one as well. Right about there. Okay, so now we need to find the x-intercepts. So to find the x-intercepts, we have to basically do what it's asking us to do over here, which is to solve this equation. So we're going to kind of knock out both of these at the same time because we'll get the same answers. All right, so we've got x squared minus 6x plus 2 equals 0. Does not appear that this one's factorable, so we are going to have to use the quadratic formula here. So we got x equals negative b plus or minus square root of b squared minus 4ac, all divided by 2a. I'll make a little note here, so if you're looking back at this, you can kind of see what we did and why we did it. This quadratic is unfortunately not factorable. So we have to use the quadratic formula. Which of course is this formula right here. So now I'll go ahead and substitute everything in. Our A is 1, B is -6, C is 2. So B is -6. We have negative, the opposite of 6 is going to be +6. 6 squared is 36. And then since A is 1 and C is 2, this would be 1 times 2 times 4, should be -8 here. And A was 1, I think. Yep. Alrighty. So let's go ahead and simplify this one more time. (36 minus 8) would be, I think that's 28. So yeah, since 28 is not a perfect square, that's kind of why we're having to do this, is because we could not factor it. And so we're going to get two answers here. X is going to be approximately, and this is something I'll put in the calculator, and my arrows just disappeared inexplicably. Not sure what's going on there. So X is approximately, and I'm just going to type this in the calculator. So you can't really see me because I've got, but yeah, I'm just going to the calculator here, typing in 6 plus the square root of 28 all over 2. I get about 5.646, and then, I mean, we could just really call that 5.6, since really the whole point of this is so that we can graph. And then the other one would be approximately 6, let's see what 6 minus square root of 28 would be, divided by 2. I get about 0.35, so I'll call it 0.4. And so these are my two solutions and my two x-intercepts. So I got one at 5.6 comma 0. And one at 0.4 comma 0. All right, those are the solutions to this equation. You can see the work that we did over here. We just used the quadratic formula. So we're going to say, you could just write it, like if you're just looking for the straight up solutions, you could just write them both like this. Okay, or you could write them separately if we want to round here. Say x is approximately 5.6, or x is approximately 0.4. Here are the exact solutions down here. Okay, so now we can go ahead and plot those 2 points, 5.6 and 0.4. 0.4 is going to be roughly right here. 5.6 is going to be over here. And now it looks like we have enough to sketch this parabola. So let's go ahead and go for it. We're going to go all the way down, and then we're going to go up. Okay, let's make that a little cleaner here. Go up through that x-intercept, and there we go. Okay. Whew. I'm going to just leave this up here so you have a chance to look at it. But yeah, just to kind of talk our way through, first we found the axis of symmetry and the vertex. The axis of symmetry is just where the h is, x equals that h. The h comma k is the vertex, that's that point down here, which in this case is a minimum because it's opening up. And by the way, it's opening up because the leading coefficient is positive. The y-intercept is just the c value here too. And then we could find the x-intercepts by using quadratic formula, or alternatively, if you can factor it, that's probably the preferable way. But you could just use quadratic formula on all these. So that's it for number 1. Let's take a look at number 2. Now in this one, our function's already in factored form. which will be convenient for when we find the x-intercepts, but we still need to find the axis of symmetry and vertex, so we really do need this in standard form. So I'm going to distribute the x to get this into standard form. That's going to give me x squared minus 6x. Notice there's no constant here, so that c term will be 0. And let's just go ahead and write out our a, b, and c. A is 1, b is negative 6, and c is 0. There's no constant here. So to calculate the axis of symmetry and get started on the vertex, we're going to first find the h value, which is negative b over 2a, or the opposite of b over 2a. The opposite of negative 6 is positive 6, and a is 1, so 2 times 1 is just 2, 6 divided by 2 is 3. So the x-coordinate of the vertex and the axis of symmetry is at x equals 3. To find the k, we are going to plug in 3 back into the equation. Well, you could actually use the standard form, or you could use this. It doesn't really matter. You should get the same number either way. I'll use the standard form. 3 squared minus 6 times 3. Now this is going to be 9 minus 18 would be negative 9. So now we've got our axis of symmetry, which is at x equals 3, and we've got our vertex at the coordinate 3 comma negative 9. So let's go ahead and plot all this stuff before we move on. 3, negative 9 is right here. Then we've got that axis of symmetry, which is going straight through the vertex. Not really necessary because the axis of symmetry doesn't really show you what points are solutions to the equation, but it can help to make sure that your graph is nice and symmetrical. Now our c is 0, so our y-intercept is just going to be at 0, and that's actually going to give us one of our x-intercepts. Because if you pass through the origin, not only are you passing through the y-axis, but you're also passing through the x-axis. So I know that has to be one of the x-intercepts, and when I go to find the x-intercepts, we'll make sure that that does actually happen. So let's calculate the x-intercepts. We want to set the equation equal to 0 and then solve it, and since they already gave us the equation in factored form, we might as well just use that one. So x times x minus 6 equals 0. A little line disappeared here. I'm having some issues with that lately. Now, since it's already in factored form, I can set each one of these factors equal to 0 individually and solve them. So either x equals 0, which doesn't require any solving, that matches up with the x-intercept of 0 that we were already expecting. And then x minus 6 equals 0. So if x minus 6 equals 0, if we add 6 to both sides, we get x equals 6. So my other x-intercept is going to be 6 comma 0. Now lastly, use the graph to solve the equation. That's where we'll actually use the x-intercepts to get our solutions here, which we already found at 0 and 6. I'm going to go ahead and plot do the best I can here trying to draw this parabola. That's decent enough. And so the two solutions to this equation, which I already found, were x equals 0 or x equals 6. And there you go. There's number 2. The graph and all the information that you need. All right, moving on to number 3. We're solving inequalities now. For number 3, we've already got it in factored form. And remember that all we really need here are the zeros, and we need to make a note of whether or not the leading coefficient is positive or negative. Now the leading term here would be x times x, which would be x squared. I'm going to make a little note here. But that does have a positive leading coefficient. So the leading term is x squared The leading term is x squared, and x squared has a positive leading coefficient. Which means that the parabola opens up. Okay, so we'll know that. Remember that the whole strategy here with these inequalities is we're going to sketch a graph, and it's not going to be as detailed as like number 1 or number 2. We don't really care about the, well, I misspelled this, coefficient. We don't really care about anything really except for where the graph is either above or below the x-axis. So the only things we need to find are the direction that the parabola opens and then where the x-intercepts are. So since we have x plus 3 and x plus 4, we know that the two x-intercepts are going to be at -3 and -4. Okay, so we're just going to do a super rough sketch here. It's not going to be detailed at all. Really, all you need here is an x-axis. Label these 2 points. Okay, so -4, -3. Oh gosh, that looks terrible. Okay, that's all right. Let me, I'm going to type that out. -4 and then -3. And then draw your parabola. Okay, so really all we need to know is that it's passing through these points, and we know it's opening up. So our parabola is going to do something like this. Okay, now we want to know, when is this function less than 0? In other words, where is the graph below the x-axis? So that's going to be down here, right? We can see this whole section is below the x-axis, and so our solution set is going to be, if we write it as an inequality, x is in between -4 and 3. So between -4 and -3. That answer is just fine. Like that answer. Or if you want to write it using interval notation, you'd say x is an element of the set. Should be a little epsilon here. And then we'll say from -4 to -3 exclusive, because it says strictly less than, so we'll say -4 comma -3. Either one of these 2 answers is just fine, but make sure you're familiar with both notations. Now, for number 4, we do need 0 to be isolated on one side, so we're going to add 18 to both sides here. Kind of clean this up. And then I'll factor. So 2 numbers that multiply to give me 18, but add up to 9 would be 6 and 3. So we have x plus 3 and x plus 6. The order doesn't really matter. Okay, so now we're ready to start analyzing this inequality. First, the leading term, just like the last one, actually I'll just copy and paste this, is going to be x squared. So that means that the parabola is going to open up. And then my x-intercepts are going to be at -3, because I have x plus 3, and then also -6. So we basically have the same thing going on with this one as we had the last one, except the part that we're looking for is going to be on the opposite side of the x-axis. Okay, I'm going to just change all these numbers here. Oh gosh. What in the world just happened? Hold on. All right, there we go. Fix it up. So we've got our 2 x-intercepts, -3 and -6. Parabola is opening up. But this one's wanting to know, when is the function above the x-axis? When is that positive? So it's going to be positive when it's above the x-axis here and here. So the way we'll write our inequality, our solution set, will be all the numbers less than -6 or greater than -3. So x is either going to be less than -6 or x is greater than 3. No, I'm sorry, -3. Right, there we go. And then if I want to write it using set notation, there are two intervals here, because we've got where x is less than -6, so that'd be between -infinity and -6, and then union, so I use the U symbol, -3 to infinity. Again, either one of these two answer representations of the solution set is fine. You can use either one. Just use the one you like better. Okay, either using inequalities or the set notation, but make sure that you're familiar with both. That's it for number 4. Let's look down here at number 5. It says find the x-intercepts of the function. So that would be the values of x when y is 0. So we want to set this equation equal to 0, x squared minus 7x plus 6 equals 0. And try to factor if you can, and I believe this one is factorable. Two numbers that multiply to give me 6 but add up to -7 would be -6 and -1, so we have x minus 6 times x minus 1 equals 0. And then when I set each of these equal to 0, using the zero product property, I can split this up. And I'll have either x minus 6 equals 0 or x minus 1 equals 0. And so x will either equal 6 or 1. Okay, so my two x-intercepts are going to be at 6, 0 and 1, 0. Those would be the x-intercepts. Number 6 says, does it open upward or downward? How do you know? This one opens downward because the leading coefficient is negative. Okay, we've got this negative x squared, and since that a term is negative, we know it's going to open downward. So I'm just going to type the graph opens downward. Okay, we know this because the leading coefficient, which in this case is -1, is negative. Okay, if it were positive, it would open up. Number 7, find the vertex of the function. Okay, so we'll start with the h. H is -b over 2a, so that'd be 12 over 2 times -2 would be -4. So that is -3. And then the k would be what I get when I plug in the h. So that would be -2 times -3 squared minus 12 times -3 minus 16. There's a lot going on here, so I think I'm just going to throw all that into the calculator. So let's see. And I'm just typing this in. -2 times -3 squared. Make sure that that -3 is in parentheses. Minus 12 times -3. Minus 16, I get 2. So the vertex is at -3, 2. Number 8 says graph. I'm going to graph this function. Okay, so first we'll find the vertex, then the y-intercept, and we'll go from there. So the vertex, first we need to find the h. The opposite of b would be positive 6 over 2 times a, so that'd be 2 times -1 is -2, so we get -3 for the h. And then for the k, that'd be this one's the opposite of -3 squared minus 6 times -3 minus 5. So you just want to be careful here. I want to be careful here to evaluate this because of all the negatives. So I'm just going to type this into the calculator. The opposite of -3 squared minus 6 times -3 minus 5 is 4. Okay, so my h is -3. Kind of move this around so we have more room here. And my k is 4. So we have our vertex at -3, 4. So I'm going to go ahead and plot that now. Negative 3 comma 4 is going to be up here. It is opening down, so I'm expecting it to kind of go like this. And we do have our y-intercept at negative 5. This is the y-intercept. Okay, negative 5. So I'm going to plot that point as well. All right, so we're looking for two x-intercepts here. And so in order to get those x-intercepts, we need to set the equation equal to 0 and then solve it. So we've got negative x squared minus 6x minus 5 equals 0. Now notice all the negatives here. I can make this a lot easier if I just multiply everything by 1. I get x squared, multiply everything by negative 1, and then it will effectively flip all the signs. So now I can go ahead and factor this. This is going to be x plus 5 times x plus 1. Okay, so I get x equals negative 5 and x equals negative 1. And so my x-intercepts are going to be at negative 5 comma 0 and negative 1 comma 0. And I will plot those here and here. All right, there we go. That's enough points. You can kind of see this is definitely going to open down, and that makes sense because we have a negative leading coefficient. So I'm going to go ahead and do my best to sketch this out, making it go through all those points. Pretty happy with that side. Then this side is just going to go down, kind of do the same thing. Okay, there's number 8. Let's move on. Now we're moving back to the inequalities, and so each one of these is referring back to this graph. It says the graph of x plus 2 squared shown below. Okay, so we don't have to worry about graphing. We've got the graph, and we're just going to use it to solve the inequalities. So this says x plus 2 squared is greater than 0. Where is it greater than 0? In other words, where is it above the x-axis? And we can see that it's above the x-axis really everywhere except for at negative 2, where it's actually on the x-axis. So we're positive here. And maybe I'll do that in green. On this interval, we're positive. On this interval, we're positive. And at negative 2, it's 0. Okay, so that's really what we want. And it's never negative. Okay, never negative. So it's never below the x-axis. 9 says, when is it positive? So there's basically two intervals here. We're going to say x is less than negative 2 or x is greater than negative 2. There's another way we could actually write this. Since we're going to include all real numbers except for negative 2, we can just say that x cannot be negative 2. And that would be a much easier way of actually writing this. Okay, now either way is fine, but you're probably better off just saying all numbers except for negative 2. So you'd say x cannot be negative 2. This way is fine, but you can see how this is a lot more efficient. Now 10 says, when is it greater than or equal to 0? So that is all the positive sections and we're at 0. So that's actually just going to be all real numbers. If you write it using set notation, which I guess we didn't really do for the last one, you would just say negative infinity to infinity. Either one's fine. Kind of like the negative infinity to infinity, but you can say all real numbers. That's fine. 11 says, when is it less than 0? So when is it negative? Well, never, right? It's never below that x-axis. So here you would just say there's no solution. And then for 12, when is it less than or equal to 0? Well, just like we said, number 11, it's never less than 0, but it does equal 0 at this one point. So the only number that's going to actually work here is going to be at x equals negative 2. Kind of a weird one, but not too hard when you actually have the graph. Okay, 13 through 16, we're matching the function to its graph. So I think what we'll do here is just kind of see if we can figure out what these are without having to break down every little piece. But let's start with 13, and we can factor this. This is going to be two numbers that multiply to give me negative 5, but add up to 4 would be 5 and negative 1, so x plus 5 and x minus 1. So that means our x-intercepts will be at negative 5 and positive 1, and we see that that's going to be here at D. Where we could see negative 5 right here, positive 1 right here, and so, yeah, this has got to be D. X squared plus 3, that has a y-intercept at 3, and actually the y-intercept might be the easiest way to answer this one because they all have different y-intercepts. I didn't really notice that on the last one, but yeah, we can verify this, that 13 does have a y-intercept at negative 5, right here. 14 should have a y-intercept at positive 3. We see that right here. So yeah, 14 has got to be C. 15 has a y-intercept at negative 3, and we see that right here. So this one's got to be B, which really only leaves us with the last one to be A, and the y-intercept's 11.25. It's a little off the graph here, but we can see that does kind of make sense, 11.25. If we were going to find the x-intercepts, you would find them at 5 and 9. But I think that about wraps it up for this unit review. As always, if you guys have any questions, please reach out and I'll try to help you out. But otherwise, thanks for watching, and y'all have a great day.